Today we'll cover TCP, HTTP, and the new protocol promoted by Google called SPDY. I don't know what the acronym is. I don't think anyone knows what the acronym stands for apart from the authors. For those of you who haven't been on my webinars before, allow me to spend a few seconds introducing myself. I've been networking since 1985 or so, started with DECnet, then moved to IP. Been technical director in my company, and now I'm chief technology advisor, which is a nice advisory role that gives me plenty of time to do consulting, blogging, creating webinars. And I'm also teaching a course at the local university called Scalable Web Application Design. And this presentation is actually part of that course. So what I'm trying to do is I'm trying to teach young people how to design web applications that will perform well over a variety of media. I just wanted to mention that this session is just one of many webinars on ipspace.net. On this slide, I'm just introducing the data center ones because today's topic has to do with data centers. I will not go into details. If you are interested in more details, please visit my website and you will find everything you need to know on it. As always, let's start with the problem. So why are we discussing these three protocols? The problem is very simple. Web pages should load in 100 milliseconds. Why is 100 milliseconds the magic number? It's very simple. Loads of scientists were doing different research in how quickly computers should respond. And here are some of the results with links if you want to research further. More or less everyone agrees that if a computer responds in 100 milliseconds, the user doesn't perceive the delay. The psychological impression is that the response was instantaneous. If the response takes more than a second, then the user's flow of thought is already interrupted. If you wait for more than a second, you start wondering, what was I doing and why exactly am I here? If it takes more than 2 seconds for computer to respond or web page to load, it interferes with our short-term memory. We start forgetting why we were doing what we were doing after only 2 seconds. 10 seconds and we lose the user. The user is no longer focused on the dialogue, the user goes somewhere else. This research is almost 20 years old. This is not something that we could blame on the new generation that is spoiled with instantaneous responses and so on. This research was done 20 years ago, and at that time, the numbers were like they were here. On the other hand, other people were doing specifically web-focused research, and the results are interesting. Most users assume that if the web page doesn't load in 3 to 4 seconds, the website is not working, and if they're not extremely interested in what's on that website, they walk away. Google did some research, and they were probably artificially introducing delay in the responses so that they could measure the behavior of users getting the usual response and the behavior of users getting delayed response. They measured and they published the result at one of the conferences in 2006 that half a second delay causes 20% drop in traffic, which for Google is enormous, considering that they are actually living off the ads that are served next to the search results. So everyone more or less agrees that the ultimate goal is 100 millisecond load time. Now the question is, how do you measure this? With modern browsers, it's very simple. Every single browser has some debugging or developer tools, and as you can see, this is actually the developer tools from Google Chrome. I went to stanford.edu. Instead of getting their website in 100 milliseconds, I got their website in 1.7 seconds. The blue line in the developer tool is where the web page is operational. It can be displayed to the user, But later on, numerous other components were being loaded so that the final web page appeared at 4 seconds. So, what's going on? And by the way, before going into those analyses, there's an interesting thing here. First, the initial web page was loaded, and then Chrome loaded all the style sheets. After the style sheets were loaded, Chrome loaded all the JavaScripts. And only after JavaScripts were loaded, at which point we could see the website, then the browser started loading the images. It's not that Stanford would have a perfectly designed website. It's good, but they probably could improve one thing or the other. Chrome does these optimizations on its own, because before you load all the style sheets, you cannot show the web page. And before you load all the JavaScripts, you cannot complete loading the web page. So style sheets are the most important resource. Next is JavaScript. And after that are all the other resources like images. And Chrome is doing this prioritization automatically behind the scenes. Now let's focus on why it takes so long. If we focus on just one entry, and it's very easy to do so, you just go with mouse over this particular request and you can see what's going on. You see that we are spending 200 milliseconds connecting, whatever that is. DNS lookup was done in 1 millisecond. Then we're spending another almost 200 milliseconds waiting. And then it takes almost 600 milliseconds to load the single web page. Every web page, as you know, has tens, and in this case, it probably had like 100 elements. And for every single element, you see here's the original web page and style sheet 1, 2, 3, 4, 5, and then script 1, 2, 3, 4, 5, and so on. So for every one of these elements, the browser has to generate a separate HTTP request. Because HTTP runs over TCP, and HTTPS, by the way, runs over something called TLS or Transport Layer Security and then TCP, if we want to understand what's going on, first we have to understand how TCP works. By the way, just focusing on TCP and HTTP will not solve the problems you have with your web application. It's important to understand how they impact the performance, but the solutions are somewhere else. So on the markup side, the most important recommendation is make fewer requests. If you can generate fewer requests, usually website will load faster. I will not go through this whole list of things that you can do. By the way, you should show this list to your application developers and ask them how many of these things they actually implement. So for example, instead of having small images, you can embed them in the web page. Instead of using rounded corners, those fancy things on the edges of the boxes, and do them with images, you could use the new CSS features in modern browsers and just tell the browser to generate the rounded corner. And one of the most important things, apart from making fewer requests, minimize cookies. Cookies are sent with every request. If the website generates 50 cookies, then 50 cookies will be sent with every single request. So you want to download a small image that has 300 bytes, and you send 2K of cookies. Doesn't make sense, does it? Next thing you can do is you can play with the browser, and here the magic buzzword is progressive enhancement. What you do is you load the initial content, and maybe you want to split the initial payload, like Facebook or Twitter is doing. You download the first screen, and then as the user scrolls down, you load more and more and more actual content. But even with the first screen, it's good if you can load some content to show first, And then in the background, you load the scripts and then you enhance the content to make it more interactive to respond to user requests and so on. On the network/transport side, the most important thing to do right is caching. If you can get the caching right, if you can push as many resources as you can into the browser, your web application will work extremely fast. There's a gentleman, Steve Saunders or something along those lines, that was focusing on fast websites for the last 10 years or so. And he recently published a research saying it's amazing, but caching is still the best mechanism to improve the performance of websites. There are all these other tricks, but still cache is king. So cache as many things as you can. Plus, other important things, prefetch resources that you know you will use, like images. Use content delivery networks so the static content is close to the consumers. Avoid redirects, reduce DNS lookups, and so on and so on. On the server side, you might need load balancing to improve the performance of the application. And also, the application developers should not underestimate the importance of back-end scripts. So, for example, if someone sends you a request that takes a long time to process, maybe it's not a good idea to wait till that request is processed and then tell the user it is okay. Maybe you should split this in two parts. Immediately sending the response back to the user so that something happens in the browser saying, "Thank you for submitting, we are processing your request," and then after a while acknowledging that the request has been completed. To get more information about my webinars, to register for an online session, or buy a recording or the yearly subscription, please visit my website.